Good morning, students. So today we will be discussing the questions on the chapter integrals. Okay, and this is a very important chapter from Karnataka CET point of view. It may fetch you 6 questions. Okay, in the upcoming exam. Okay, so it may fetch you 6 questions, and 2 questions you may get based on the same topic, that is from application of integrals. Okay, so you can expect 6 to 8 questions, 6 to 8 questions from this chapter. So it's a very important chapter. So after differentiation, this chapter fetches more number of marks. So differentiation fetches you around about 6 to 8 marks, and integration also, integration along with application of integration, it fetches you 8 marks. Okay, so 8 plus 8 16 marks you may expect from calculus part. And then another topic, that is differential equation, may fetch you 3 questions. So you can expect round about 18 questions, 18 to 20 questions from calculus part, second year. So this also is a very important chapter. Okay, so I will be trying to solve around about 40 examples on integrals based on the previous year's question papers. You all also at home try to solve at least 5 examples on every concept. So I will first tell you the concepts, important concepts from where the questions are occurring. So based on these concepts, you all also practice some more questions at home. Okay, so we will begin with the first question. So before that, we will discuss the important concepts. Okay, so first, okay, so integration, okay, by substitution method. Okay, so this is the first concept from where you may you may get a question. Next, by parts. Okay, integration by parts. Okay, and then okay, partial fractions, integration by partial fractions. Okay, so on all these methods you try to solve at least 10 examples. Okay, 10 objective type examples. Okay, next, fourth, okay, special types. So special types are there. Okay, so in these special types, okay, you have formulas of a root of integration a square plus x square. Okay, then 1 upon root of x square minus a square. So such 9 special type formulas are there. So based on these, you try to solve at least 10 examples each, and then you may get 2 questions, at least 2 questions from properties of definite integrals. Okay, properties of definite integrals. So properties of definite integrals may fetch 2 questions. Okay, so again you need to solve at least 20. Okay, so properties of definite integrals. Definite integrals. Next, the sixth one is application of integrals. So here you have the examples related to areas of the curves. Okay, areas bounded by the curves. So these are the main concepts in integration which you need to focus on. Okay, so for every concept you try to solve at least 10 examples each. Okay, 10 examples each, and then practice all the previous year papers. Okay, so it will fetch you 6 to 8 marks. Okay, 6, maximum 8 marks. Okay, it will fetch you in the upcoming Karnataka CET 2024. Okay. So we will discuss. So I have kept two classes for this today and tomorrow. Both the days we will be discussing the examples based on integrals. Okay. So one by one we will start our discussion. Okay. So see the first question here, the value of -1 to 2. Okay, -1 to 2 integration. Okay, integration of mod x upon x from -1 to 2 dx is. Okay, so we need to simplify and find the value of what integration of mod x upon x dx. Okay, so here we are making use of the properties of integrals. Okay, properties of integrals. Okay, so see here the solution, the given solution, we will discuss it. So here we are making use of the property. So a to c f of x dx. Okay, so here we can write it as a to b f of x dx plus b to c f of x dx. Okay, so see here the interval given is from -1 to 2. So we can split the interval. We can split this interval as -1 to 1 and then -1 to 1 and then 1 to 2. Okay, so see in -1 to 1. Okay, in -1 to 1. So when it is less than 0. Okay, when it is less than 0. Okay, we can consider the integral. See the mod x, I can consider it as -x. So minus x upon x, it will be -1. So the integral of this will be what? Minus x. Okay, it will be minus x. Similarly, mod x upon x, here we will consider it as positive. So the answer will be x. Okay, the answer will be x. Okay, so now on substituting, say in this integral, we need to replace it by -1 and 1. So it will be 1 1 -1 minus of -1, it will be +1. So here the first integral will be 0, and in second case the integral will be 1 to 2. So it will be 2 minus 1. So the final answer will be equal to 1. Okay, so here we have made use of the property a to c f of x dx. Okay, is equal to a to b f of x plus b to c f of x and dx. Okay, so this has occurred from properties. Okay, properties of and definite integrals. Okay, properties of definite integrals. Okay, so so it has occurred from this concept. So again, you try to practice some more examples based on this property. Next, question number 2. Yes, so 0 to pi cos 4x plus sin 4x dx is equal to. Okay, dx is equal to. Okay, so again this question has also occurred from the properties of integration and definite integration. So the property is 0 to a f of x dx. Okay, 0 to a f of x dx is equal to. Students off the mic, don't on the mic, keep yourself mute. This is the second question is integration from, okay, integration of cos raised to 4x upon cos raised to 4x plus sin raised to 4x from 0 to pi and dx. Okay, so integration from 0 to pi cos raised to 4x upon cos raised to 4x plus sin raised to 4x and dx is equal to. So this question has also occurred from the based on property, and in board level you might have solved this example. It's the same example. Okay, at board level also we have solved such examples. So see the solution for this. Yes. So here we are applying the property. So see 0 to pi. So you can write it as 2 times 0 to pi by 2. Okay, cos raised to 4x upon cos raised to 4x plus sin raised to 4x and dx. So when we simplify this, okay, when we simplify this, we get it as 2 into pi by 4, which is equal to what? Pi by 2. Okay, which is equal to pi by 2. So 0 to pi cos raised to 4x upon cos raised to 4x plus sin raised to 4x. We are writing it as 2 times 0 to pi by 2 cos raised to 4x upon cos raised to 4x plus sin raised to 4x dx, which is equal to 2 times pi by 4, or which is equal to pi by 2. So the option B is the right option. Okay, option B gives us the right answer. Okay, so similarly you can solve it by using the property, other property also. 0 to a f of x dx is equal to 0 to a f of a minus x dx. So you will get equation 2, and by adding equation 1 and 2, again you can get back the same answer. Okay, you can get back the same answer, and that is pi by 2. Okay, so in such type of examples, okay, in most of the cases either the answer is the upper limit. Okay, either the answer is the upper limit, or it will be equal to pi. Okay, answer will be equal to pi, or it will be equal to what? Pi by 2. Okay, pi or pi by 2. Okay. So you can solve this both the ways. You can solve either by using this, whatever the procedure is given, using this also you can solve it, or you can solve it by using the property. Just I will mention you the property for home work. You can try this. So see 0 to a f of x dx is equal to what? 0 to a f of a minus x dx. Okay, so see the same thing. What you can do is when you apply the property, this will be in the form of what? 0 to pi cos raised to 4 pi minus x divided by cos raised to 4 pi minus x plus sine raised to 4 pi minus x. Okay, so dx, when you simplify this, we get it in the form of 0 to pi. Okay, 0 to pi cos raised to 4 cos pi minus x is minus cos x, but it is power is 4, so you can write it as cos raised to 4x. Okay, similarly, see cos of 4 raised to pi minus x. Okay, it will be again cos raised to 4x. Okay, and then this is again sine raised to 4x. Okay, so when we are adding this equation 1 and 2, okay, we are getting 2 times this. Okay, so you need to make use of this property and simplify. Next example number 3. Okay, example number 3. Yes. Okay. So example number 26. So if f of x is equal to f of pi plus e minus x, and e raised integration from e to pi f of x dx is equal to 2 upon e plus pi, then integration of e raised to pi x f of x dx is equal to. Okay, so see e raised e to pi f of x dx is, they have given 2 upon e plus pi. They are asking us the value of e raised to pi x f of x dx. Okay, so only one extra thing, that is they have multiplied the function with x. Okay, they have multiplied the function with x, and they are asking us the integral of this. Okay, how to simplify the pay attention. We'll try to simplify this. Okay. So see here already f of x dx integration e to pi f of x dx is given to us. Okay, it is given to us. We need to calculate the integration e to pi x f of x dx. Okay, x f of x dx. Okay, so here we are first making use of the property. So again, it is occurring from properties of definite integral, this question. So see a to b f of x dx, okay, can be written as, okay, it can be written as a to b f of a plus b minus x and dx. Okay, so this is the property we are using. So using this property, I can write the given integral I as, say, the given integral I can be written as, say, e to pi, e to pi, okay, e to pi. So where there is x, okay, where there is x, see, this is the integral. Okay, this integral we are considering it as I. So it is e to pi x f of x dx. So where there is x, replace it by what? Replace it by a plus b minus x. Okay, so in place of a we have here pi. So this will be pi e plus pi. Okay, or pi plus e. minus x, okay, minus x, f of pi plus e minus x and dx, okay. So this will be the value, okay. And on simplifying it, okay, on simplifying it, okay, we get, so we can simplify, see, on simplifying this, see, this is already we know, and the value of pi plus e minus x is equal to f of x. So this can be written as e to pi plus e minus x f of x and dx. Okay, this will be f of x dx. So this I can consider it as equation 1. Okay, so this is our equation 1. Okay. Okay, now what we can do is, so see, when we add both, okay, when we add both, say this is I, so this I will consider it as equation 1. This is equation 1, and this I will consider it as equation 2. So when I add it, I plus I, it will be 2I. Okay, I plus I, it will be equal to 2I. Okay, and we can see the common part. Okay, so pi plus e minus x, and here we have x, so we can add those parts. Okay, so it will be just pi plus e integration from e to pi f of x dx. Okay, so this, on simplifying, we get, see, pi plus e will remain as it is constant. See, when we add this pi plus e minus x, and here we have x, okay, plus x, okay, so that will cancel, and we know this value already, it's given in the question here, it is 2 times e by pi, e plus pi, e plus pi will cancel, the answer will be equal to 2. Okay, so the properties of definite integrals are playing a very important role here. Okay, these all questions, whatever the 3 questions we discussed, all were based on the properties of what, and definite integrals. Okay, so the answer will be equal to 2. Okay, so option so see, 2 will be the answer. Okay, we need to substitute the value, sorry, still we need to substitute the integral here. So when we substitute the integral, okay, to I, sorry, to I, it will be 1 minute. What step we need to do? See, this will be 2I, or I will be equal to what? I will be equal to 1. Okay, I will be equal to 1. So the final answer will be option C. Option C, that is 1 will be the right answer. Next, question number 27. If the linear function f of x and g of x satisfy integral 3x minus 1 cos x plus 1 minus 2x into sin x dx, which is equal to f of x cos x plus g of x sin x plus c, and then, okay, so they are asking what are the values of what are the values of f of x and g of x. Okay, what are the values of f of x and g of x. Okay, see here, pay attention. So see, we need to calculate the value of f of x and g of x. Okay, so here, see, we are considering the given function first. So see, 3x cos x. So when we simplify it, we get it in the form of what, 3x cos x minus cos x plus sin x minus 2x sin x and dx, which is equal to f of x cos x plus g of x sin x plus c. Okay, next, taking 3 common, we get x cos x minus sin x minus cos x minus 2 times integral of x sin x and dx. Okay, x sin x dx. So on simplifying this, we get it in the form of, so see, integration of x cos x, we need to apply by parts. So x as it is, cos x integration is sin x. Next, one integration, the differentiation of x will be equal to 1, and cos x integral will be sin x and dx. Similarly, minus sin x minus cos x will remain as it is, and then again we need to apply integration by parts here. So we get 2 into x minus cos x minus 1 into minus cos x and dx. So on simplifying these terms, we get 3x sin x plus 3 cos x minus sin x minus cos x plus 2x cos x minus 2 sin x plus c. On simplifying, we get cos x, when we take common, we get it as 2 into x plus 1. And when we take sin x common, we get 3x minus 1. Okay. So we can see when we compare it with the given integral, we get in the form of c. In place of f of x, we have 2x plus 1. Okay, 2 into x plus 1, and in place of g of x it is 3 into x minus 1. Okay, so this question has occurred. Okay, so you need to make use of by parts rule. We have applied by parts rule twice here. Okay, once we have applied by parts to solve the integration of x cos x dx, and then to solve the integration of x sin x dx. Okay, next example number 5. So the value of the integral minus pi by 4 to pi by 4 log of sec theta minus tan theta d theta is. Okay, so the value of the integral, okay, value of the integral log of sec theta minus what tan theta is. Okay, I think this question you might have come across in the theory part also. Okay, in the theory part also you might have solved this example. If you come across this, again this is based on the properties of definite integrals. Okay, it is based on the properties of what definite integrals. Okay, so see, pay attention, we will discuss the solution for this. So it is log of sec theta minus tan theta d theta minus pi by 4 to pi by 4. Okay, so first we will make use of the property. Okay, we will make use of the property and then simplify it. Okay, here the answer is A, but we will try to simplify it. Most of you have answered it 1. Okay, has answered it as A. Okay, see, pay attention how we can solve the procedure we will discuss. The steps. Okay, so first what we are doing is we are replacing the first step. What we are doing is we are replacing theta with minus theta. So when we replace theta with a minus theta, we get it in the form of see a log of sec of minus theta, it will be sec theta only, and log of tan theta minus tan theta, it will become okay tan theta. Okay, so you will get it in the form of log of sec theta plus tan theta. Okay, or we can write it as log of sec theta plus what tan theta and divided by what 1. Okay, and 1 we know by using the trigonometric identities, we can write it as in the form of log of sec theta plus tan theta and divided by 1 can be written as secant square theta minus what tan square and theta. Okay, and on simplifying again we get log of, so see, positive negative both values you will get. Okay, so you will get it in the form of what, again on simplifying you will get it in the form of okay 1 divided by sec theta minus what tan theta. So only just we are substituting and simplifying, or on simplifying it further, see, on simplifying it further we get, okay, we get this as equal to minus log of, okay, minus log of sec theta minus what tan theta. Okay, minus tan theta. So we can see this particular function. So see here we have applied the property We have replaced x with minus x. Okay, x with minus x. So when we replace x with minus x or theta with minus theta, we can see the function is, okay, we are getting f of x. So see, f of minus x, we are getting it as what? Minus f of x. Okay, so such type of functions are what? Odd functions. Which functions? Odd functions. And for odd functions, we know the property minus a to a, f of x and dx is equal to what? 0. So directly this answer will be equal to 0. So 28th, the option A, that is 0, will be the right answer. So again, this is based on the property of definite integrals. Okay, so you can see maximum questions have occurred based on the properties of definite integrals. Next question, question 29. Yes. Okay, question 29. Sine 2x upon sine square x plus 2 cos square x. Sine square 2x upon sine square x plus what it is? 2 cos square x. Okay. Yes. Okay. So we will discuss the solution for this. So here what we are doing is let I is equal to sine 2x upon sine square x plus what? 2 cos square x. Okay. Next, say sine 2x, using the trigonometric formula we can write it as 2 sine x cos x. Okay, 2 sine x cos x. And we know that sine square x plus what? 2 cos square x is there. So sine square plus sine cos square, it will be 1 plus cos square x. Okay. Now we are replacing 1 plus cos square x as t. So when we replace 1 plus cos square x as t, the integral, the derivative of 1 will be 0. Cos square x and derivative will be minus 2 sin x cos x dx is equal to dt. So the entire numerator part can be replaced by what? Minus dt. So we can write it as dx is equal to minus, okay, dx is equal to, we can write it as, okay, see, this is completely equal to t. So we can write I is equal to minus dt upon t. Okay, minus dt upon t. Or on simplifying, we get 1 upon t integral will be log t. So this will be minus log t plus c. Or the value of c is nothing but 1 plus cos square x plus c. Okay, 1 plus cos square x plus c. So the option C gives us the right answer. Okay, option C, minus log of 1 plus cos square x plus c. Okay, so this will be the right answer. Next example, example number 30. Okay, so such type of examples occur every year, most of the time, or alternate years this example has occurred. Okay, so it is again based on the property. Okay, this question is based on the property e integration of e raised to x. So by parts. Okay, it is extension of by parts only. Okay, so by making use of the formula. So in the same example, in the same exercise, there is a formula for integration by parts. Okay, so using that formula, we can simplify this. So the formula is e raised to f of x plus f dash of x dx is equal to e raised to f of x plus c. Okay, the formula is e raised to, see, the formula over here we are using is, okay, e raised to x f of x plus f dash of x dx is equal to e raised to x f of x plus c. Okay, so this is the formula we are using. E raised to x f of x plus f dash of x dx is equal to e raised to x f of x plus c. Okay, next, pay attention. So here Pay attention. So I is equal to, we are considering integration e raised to x 1 plus sin x upon 1 plus cos x and dx. Okay. So what we are doing here is, okay, 1 plus cos x, at least in the denominator, we are replacing it as 2 cos square x by 2. Sin x, by making use of the formula on integrate on in trigonometry, we are making use of this formula sin 2x. See, sin 2x is equal to 2 sin x cos x. Okay, and similarly sin x will be equal to what, 2 sin x by 2 into what, cos x by 2. So by making use of this formula, we are replacing sin x, and by replacing sin x, we can replace 1 as cos square x by 2 plus sin square x by 2. Okay, and this complete term can be written as cos x by 2 plus sin x by 2 whole square. Okay, so you will be getting it as cos x by 2 plus sin x by 2 whole square, and whatever the 2 is there with cos square x, okay, you can take it outside common. Okay, next, on simplifying it further, see what do we get. 1 by 2 integration e raised to x. So cos x by 2 and 1 square term will cancel, and sin x by 2 upon cos x by 2, it will be tan x by 2. Okay, whole square dx. Okay, next we can simplify it further. So see, it can be written as 1 by 2 integration of, okay, 1 by 2 integration of tan x by 2 whole square. Okay, we can simplify it and write it as sec square x by 2 plus what, 2 tan x by 2. Okay, 2 tan x by 2. Now we can see that yeah, the first function is what, tan x by 2. Okay, tan x by 2, and we know the derivative of tan x by 2. The derivative of what, tan x by 2 is secant square x by 2. Okay, secant square x by 2 into 1 by 2. Okay, so what we are doing here is, so by using this formula just now we discussed, if the uh, given expression is in the form of e raised to x into f of x plus f dash of x dx, it will be equal to e raised to x f of x. So here f of x is equal to 2 tan x by 2, or say I will be equal to this 1 by 2 as it is e raised to x 2 tan x by 2 plus c, which is again equal to e raised to x tan x by 2 plus c. Okay, e raised to x tan x by 2 plus c will be the final answer. Next example, question number 31. So see, differentiation and integration, it involves the trigonometric formulas. So the more you are perfect with the trigonometric, inverse trigonometric formula, it will help you to solve the examples on differentiation and integration. Okay, and see, still you have 10 days left with you. So every day, please try to practice some formulas. Okay, at least 3 chapters formulas you can practice every day. Okay, so try to practice the formulas. So more you are perfect with the formula, you may find the examples easy. So see, next example, question number 31. So 0 to 4 log of sin x plus cos x upon cos x dx is equal to, okay, is equal to. So I will give you 2 minutes time. You all try to solve and tell me the answer quickly. 31. Try it on yourself. Okay, try solving it. 2 minutes time I will give you. Okay, if you don't get, I will solve it. students. Okay, so most of you have answered this. Okay, I think 3 students have answered D, and one has answered C. Okay, so we will check it. See, pay attention. Okay, so see how we can solve this one. So here, first we need to again make use of trigonometry formulas here. Okay, so if you are good with trigonometric formulas, you will find it easy to understand the solution. So here, what we can do here is first say 0 to pi by 4. Okay, so whenever limits are there, we need to make use of the properties. See, I will divide it by cos x. Okay, so if I divide it by cos x, I will be getting it as tan x plus 1 and dx. Okay, we will be getting it as tan x plus 1 and dx. So 0 to pi by 4. Okay, I'll consider this as I. So I will be equal to 0 to pi by 4 log of 1 plus tan x dx. Okay, 1 plus tan x dx. Okay, now what I will do is again we will be making use of the property 0 to a. Okay, a to b f of x dx can be written as uh, okay, it can be written as a to b f of a plus b minus x and dx. Okay, so we can write it 0 to pi by 4. Okay, this I will be equal to, this is our equation 1. So on simplifying, we get log of 1 plus tan of pi by 4 minus x dx. So on simplifying this further, see what do we get? I will be equal to 0 to pi by 4. 0 to pi by 4 log of, okay, log of 1 plus pi by 4. Okay, so we can write it as 1 plus, we know pi by 4 value is 1, so it will be 1 minus tan x divided by what? 1 plus tan x dx. So on simplifying again further, we get I is equal to 0 to pi by 4. Okay, so when we take the LCM, we get it as 1 plus tan x, 1 minus tan x. So on simplifying, we get 2 divided by 1 plus tan x dx. Okay, next the last step what we can do here is, so see we can write this as I is equal to, by using the log, we can write it as 0 to pi by 4 log 2 dx. Okay, minus 0 to pi by 4 1 plus tan x dx. Okay, and see from the given question, okay, from the given question equation 1, we can see this is nothing but I. Okay, so equation 1, see, is 0 to pi by 4 log of 1 plus tan x dx. Okay, so what we are doing is this, I will write it as I plus 0 to pi by 4 log 2 dx minus I. So when we shift I on the LHS, we get 2I is equal to, integration of constant will be x, so it will be x log 2. Okay, integral from what? 0 to pi by 4. Okay, so the answer will be 2I will be equal to pi by 4 log 2, or on simplifying we get I is equal to pi by 8 log 2. Okay, so pi by 8 log 2 will be the answer, that is option D. Okay, so most of you have given the correct answer, option D. So this is the procedure. So again here we are making use of the property of integral 0 to a to b f of x dx is equal to integral from a to b f of a plus b minus x dx. Next question. Okay, so integration of sine square x upon 1 plus cos x. Okay, so sine square x, we know we can write it in the form of what? Sine square x, we can write it as 1 minus cos square x. Okay, so this is very simple example, it has occurred in 2015. Okay, so just see, we will go through the solution of this. See, I is equal to integration of sine square x upon 1 plus cos x dx, or sine square x we know it can be written as what, 1 minus, it can be written as 1 minus what, cos square x is 1 minus cos square x. So 1 minus cos square x, again apply the formula a square minus b square. So here the next step will be equal to what? Okay, it will be equal to 1 minus cos x into 1 plus what, cos x, whole divided by 1 plus cos x dx. So see, 1 plus cos x, 1 plus cos x will cancel. The remaining integral will be 1 minus cos x dx. So integration of 1 is x and integration of cos x is minus sin x plus c. So the final answer will be x minus sin x plus c. Okay, next example. So minus pi by 4 to pi by 4 dx upon what, 1 plus cos 2x. Okay, 1 plus cos 2x. Okay, so this example also you can solve it. Okay, so see, 1 plus cos 2x, so again we have to make use of the same property, that is minus a to a f of x is equal to what, even and odd function. So if it odd function, it will be equal to 0, and if it is a even function, okay, then we can proceed further. So we will discuss the solution for this. So see, I is equal to minus pi by 4 to pi by 4 dx upon 1 plus cos 2x, or we will get it in the form of what, minus pi by 4 to pi by 4 dx upon 2 cos square x. Okay, 2 cos square x. So here this f x 1 upon cos square x. Okay, 1 upon cos square x. Cos square x is nothing but sin square x. Okay, it will be, see, f of x 1 upon cos square x. Okay, so this 2 is constant, keep it outside. And now see, we can see, after substituting the value of 1 plus cos 2x as 2 cos square x, we can see cos square x is a even function. And we know for even function, the integral, the definition or the property is integration of f of x dx is equal to 2 times f of x dx. Okay, so here we will get 0 2 times 0 to f of x dx. So the answer A will be the right answer. Okay, because we get the integration as secant square x, and the integration of secant square x is tan x. So 0 to pi by 4. Okay, 0 to pi by 4, when we substitute we get tan pi by 4, and tan pi by 4 minus tan 0 will be equal to 1. So the answer is option 1. Next example, question number 34. Okay. So the next example is 1 upon x square, x raised to 4 plus 1 raised to 3 by 4 dx is equal to, okay, dx is equal to, so here we are solving it by substitution method. Okay, to solve this substitution method, we need to make an adjustment inside the bracket. See here the solution we are discussing, and we are solving this by making use of a substitution method. Okay, by making use of substitution method. So first what we are doing is we are considering the given integral I as integration of 1 upon x square plus 1 raised to 3 by 2. Next step, what we are doing is we are multiplying and dividing by what, x square, or we are taking, see, on simplifying, what do we get here? So first what we are doing is in the denominator part we are taking out x raised to 2 common. So when we take x raised to 2 common, so outside we get x, see, x square, x raised to 4 first we have taken common, so it will be 1 upon 1 plus 1 upon x raised to 4, so it is nothing but 3 of 3 4. Next one, simplifying, cos x, okay, cos x, okay, so see, not cos x, okay, so here what we are doing is this will be adjusted, see, x square into x raised to 3, it will be x raised to 5, and in the bracket we get 1 plus 1 upon x raised to 4 raised to 3 by 4. Next we are replacing 1 plus 1 by x raised to 4 by t, so the value will be equal to minus 4 upon x dx, which is equal to dx upon d, okay, dx upon x raised to 5 and minus dt upon 4. So by solving the further we get I is equal to minus 1 by 4, okay, dt upon t raised to 1 by 4, okay, t raised to 1 by 4 minus 1 upon 4 t raised to t into minus 3 by 4 plus 1 divided by minus 3 by 4 plus 1. So on simplifying it further, we get, on simplifying it further we get it in the form of, okay, you can see we get it in the form of what, I is equal to minus 1 by 4 dt upon t raised to 3 by 4, and t raised to 3 by 4 value will be minus 1 by 4 x raised to minus 3 by 4 plus 1 upon minus 3 by 4 plus 1. So on simplifying we get minus t raised to 1 by 4 plus c, or replacing t with the substitution what we had considered 1 plus 1 upon x raised to 4, we get minus 1 plus 1 upon x raised to 4 raised to 1 by 4 plus c. So option, okay, c will be the right option. Option c gives us the right option. Next, one more question, last question for today's class. So the next question is again same, the value of e raised to x, okay, e raised to x1 plus x divided by cos square e raised to x into x dx is equal to, okay, so we need to simplify it by making use of the properties. Pay attention. So see what we are doing here, we are making use of the substitution method. So e raised to x into x, we are substituting it as t, so x e raised to x is equal to t, or x integration will be 1 e raised to x as it is. Next x as it is e raised to x will be integration dx is equal to what, dt. On simplifying we get I is equal to dt upon cos square t, and we know reciprocal of cos square t is x square t, okay, and dt, or derivative of sec square t is tan t plus c. So in place of t again we need to replace the values x e raised to x plus c. Okay, so this is the question number 35. The answer is option B. So this has occurred by substitution method. Okay, so see whichever concepts we had discussed earlier, from there one or two questions will occur. Next question, example number 35. Okay. So the question here is integration of e raised to x, x square tan inverse x plus tan inverse x plus 1 upon x square plus 1 and dx is equal to, okay, is equal to. So we will discuss this final question for today's class. So see, e raised to x, we are writing, simplifying and writing it as x square tan inverse x plus tan inverse x plus 1 divided by x square plus 1. So see, tan inverse x is common, so it will be 1 plus x square tan inverse x plus 1 upon 1 plus x square. Next, on simplifying, see, 1 plus x square will cancel. and we get 1 upon 1 plus x square dx. Now what we can do is we can apply by parts here, okay, but this is e raised to x tan inverse x dx, and in the second case it is e raised to x 1 upon 1 plus x square dx. Now see tan inverse, when we apply by parts here we get, for the first case when we apply by parts we get tan inverse x dot e raised to x, and for the second part when we apply we get minus 1 upon 1 plus x square e raised to x dx plus e raised to x 1 upon 1 plus x square dx. Okay, so this the final answer will be option A, and the remaining questions we will discuss it tomorrow. Again, tomorrow also we will be discussing the questions on integration, and on Saturday we will discuss the question on application of integration. So once again I am telling you this chapter is fetching you 8 marks. Okay, so it's a very important chapter. You to try to practice the formulas as well as examples on this. So we will meet tomorrow. Take care. Bye.